And what is it? It's essentially a managed Hadoop service. So if we go back,
You have Yarn, which is a resource manager on top of that. And then on top of Yarn, you have MapReduce for batch execution. MR5 now Tez is the default execution engine for things like Hive. And if you get better performance, you can run batch, but it can also work at more interactive speeds with Tez sessions. And then you also have Spark on Yarn as well. And then on top of that, you can run higher level languages like Hive, which is SQL over MapReduce or Tez, Spark SQL, streaming, Scoop, those sorts of things. But you can also choose to install other distributed applications in your cluster, including HBase and Phoenix, HBase being basically a NoSQL database in the Hadoop ecosystem, and Phoenix, which plugs in right on top, giving you low latency SQL over your NoSQL tables, and you can create secondary indexes. It's a very, very cool application. And also Presto, which we'll show a little bit later, which gives you ad hoc SQL, low latency SQL over data in S3 or HDFS. And then alongside the stack, you have a variety of user interfaces that you can choose to install, like Hue, which we'll show a little bit later, giving you SQL interface and metastore management. Metastore is all of your tables that you might create in Hive. Zeppelin, which is an interactive notebook, which is becoming very popular among data scientists. Ganglia, which is a monitoring system. And then, there's also other things around, Hive Server 2 and Spark Drift Server. There's a bunch of other ways that you can interact with these core applications in your cluster. And the EMR service makes it easy to choose which applications you want.
how does EMR work? Works is you put your data into S3. You then choose the Hadoop distribution that you want for your EMR cluster, the number of nodes that you want in the cluster, so a number of options there. And then once that cluster is finished, it will actually output the results back to S3. And that then means that because your data is now safely in S3, which offers you 11 nines of durability, you can potentially shut that cluster down if you like. One of the other things you can do though is you can easily resize the cluster. So if you start your processing and realize actually this file is a little bit bigger than we thought, we're going to need a bigger cluster, then you simply add more nodes, and then Hadoop will take care of distribution of the data, and then you can churn through your job a lot more quickly. One of the other nice things that customers like about having the data in S3 is potentially they sometimes like to launch parallel clusters using the same data set.
Select EMR. Now we're at the EMR page. Click Create Cluster. We leave the cluster name as default My Cluster. All the logging of this cluster will be automatically saved to S3 for future retrieval. There are two launch modes. With cluster mode, EMR will create a cluster with a set of specified applications. You can add steps to the cluster after it's launched. We want to install Spark on top of the Hadoop cluster, and we don't want the cluster to terminate automatically after the job is done, so we choose the cluster mode. This vendor option specifies the vendor from which you want to select the software release and applications for your cluster. We choose Amazon. This release option specifies the software and Amazon EMR platform components to install on the cluster. Amazon EMR uses the release to initialize the Amazon EC2 instances on which your cluster runs. The latest release label is selected by default. The application option determines the applications to install on your cluster. Here we want to install Spark on top of it. The Instant Type option determines the Amazon EC2 instance type that Amazon EMR initializes for the instances that run in your cluster. We use the default M3.xlarge instance, which has 4 CPUs and 15 GB of memory. The number of instance option determines the number of Amazon EC2 instances to initialize. We
go to our own setup. So let's create a template. Amazon, they are giving Amazon EMR and Mapper as the commercial distribution, but here you have various other different open systems. Now in one of the slides you have seen that they are using Pastro and Hue and Hive, Pig, etc. When you choose one of these three platforms, Cloudera, HDP, Hortonworks platform or Mapper, they bundle all the Hadoop ecosystem product and make it workable for the enterprises. For our example, we have taken Apache Spark. We have different version. Here we have chosen 1.6 as the version. Choose your flavor. Like there they are choosing the various types of mc.large and m.xlarge, etc. Here you can also choose. Now we have taken a 2 CPU, 2 GB RAM and 20 GB disk space. Also say that whether should be accessible by the other tenant or it is protected for your own tenant. What is the node process? Which means that if you are defining this template for master node, then what all process will run there, and if you are choosing a slave node, what all processes we are will be running there. And then finally you say that when what is the security policy that you want to apply. If you just leave it as auto, by default the system will generate all the required firewall policies. Apart from that, for your own convenience, you can put the SSH and ping on top of that. So using all this, I have already created one master. I also wanted to show you something else, that if I would have chosen a HDP or a mapper, you can choose which process which will run on which node. So you're creating a node template, so you can name it as a Plume node and then install only Plume. You can create it as a Hue, then Apache Hue will be installed on top of that. These are management processes, but this, if you are creating a streaming cluster, then the Kafka will be installed, and then for Kafka Connect for HDFS and JDBC can be done. Similarly, you can come little below. You can see Pig, Mahout, Scoop, Hive, all of them are bundled and they can be installed. HBase, you go to cluster template, and within the template you include how many such node will be there. Here I am creating a cluster template, and I am saying that you should have this many node here. Okay, slave node 1 and master node 1. I could increase this number to 2 or 3. So likewise, I can, if there are Kafka and if there are Impala or if there are Hue server, I could select one of them and then add it here and tell that how many of them I require. That's the purpose here. Apart from that, if I want some fine tuning of the parameter of HDMS or Spark, those lists are also available here. Click on the launch cluster and it will start launching a cluster. Let's say this cluster name is C9, and then template is, this is where I am choosing the template. On the cluster I should be able to log in with my own key pair and your choice of network where you want to launch it. Okay, and then say launch. It will show here that the launch has been done. You can come to this place. This is creating one cluster. Meanwhile, let us go to Amazon video and see what they are doing.
Using SSH. If we do not select the key pair, you cannot connect to the cluster. I have already created several ECD key pairs, so I pick one of them from the list. If you haven't created one yet, just follow the link to create one. For the rest of the permissions, we go with the default options. Then we click Create Cluster to start the provisioning. Now, as you see, the cluster is in starting state, which means the cluster is being provisioned.
Now, the difference between this and the OpenStack approach, which I showed from our environment, is that if you have to launch another cluster, you have to go through this entire process once again. Whereas in this case, since the template is already available to me, you can just create here and launch another cluster without giving all the details. That's the benefit of having a template. We come back and start.
This process takes about 10 to 15 minutes to complete. After the cluster is successfully created, the state will turn from starting to waiting. Next, we'll need to update the security setting so that we'll be able to access the Spark cluster from our local machine via SSH. Here we click the link for security groups for the master, then select the second entry for the master group. Make sure you select the master one, not the slave one. Then click Inbound Type. Edit. Click Add Rule. In the Custom TCP Rule column, we select SSH. In the Source column, we select Everywhere. What this means is that we're going to create a new rule to allow us to SSH into the master box from everywhere as long as the private key is present. Then click Save to save the new rule.
Now, similar to this, the cluster has been already created. You can see it has taken 2 minutes 58 seconds to create the cluster. Now it is starting the Spark processes here. So it will come within next few minutes. I wanted to show you where do we provide the security group. You have noticed that I had created one SSH ping security group, and that is what I have given inside the template. And as you can see that here I have given the similar rule as 22 coming from anywhere. Yeah, so you can see the cluster has come up and it has taken exactly 4 minutes 52 seconds. The cluster is up. We have heard from them that it has taken them 15 minutes just to start the cluster. Come back here and let's start.
Next, let's prepare our input data source, or select S3. Let's create a new S3 bucket for our Spark job. A bucket is a logical unit of storage in S3. Objects are created under buckets. Here, we name our S3 bucket Stack Overflow-Analytics. Then click Create. Just select the newly created bucket name. Then click Upload. Select Add Files. Choose the Stack Overflow server file. After the uploading is complete, we can see the CSV file appears under the bucket. Next, we need to make some changes to the source code of our Spark application.
How do we do it in? We have to go to Object Store. This is equivalent to S3, and the container, which is equivalent to bucket. Big data, not public, private. So within big data, I can create a folder. Its name is input. I create another folder whose name is bin, and I create the last one whose name is. Now inside the input folder I want to upload this particular file. I am taking it as a, I'll show you how the file looks like. This is a 5 MB file, and this file is about a log of one of our server. I upload this file. Inside the big data bin, I want to upload my program files. Do here. This is my program, which does nothing but what word is getting repeated how many times. That is what is the program is all about. In here, this is my programming file, and output data is blank. Let's go there.
Let's open the Stack Overflow server file under the Spark SQL package. The only thing I'm going to set is the application name. The application will get the rest of the setting from the EMR cluster at runtime. The other change we need to make is to replace the input file path to S3 path, so that each Spark cluster will load the file from S3. The S3 path format is...
Please note here that they are changing the input file hard coding in the jar file. What we'll do is inside our jar file, we have kept this as a variable, and that variable will be supplying it from the GUI itself, making it more flexible.
S3 end column / bucket name / file name. Now we can go ahead to rebuild our jar file. Next, let's upload our jar file to S3 as well. Click the bucket name and click Upload to select our jar file to upload. Now we have our Spark jar file and input data source ready on S3. Let's log in into the Spark master machine via SSH. Click the SSH link under our cluster page. If you're running Windows, just click the Windows tab. Then follow the instruction to SSH into the master machine. You will need to install PuTTY. Since I'm using a Mac machine, I click Mac and Linux tab. Then copy the SSH command and paste it into a terminal. Make sure there is an EC2 private key file at the path to the private key file. If not, you will need to update the path to the point to the right location. Then hit enter to SSH into the host. Now we're inside the master machine of the EMR cluster. Let's fetch the jar file from S3 to the master machine here for execution. We run AWS S3CP command, which can copy files from or to S3. Then supply the source file path, which is the S3 file path. The format is S3 : bucket name / file name. We supply the destination path, which is current directory, so just put a dot sign here. Hit enter to start fetching the file from S3. After the jar file is downloaded, we can submit the jar file to the Spark EMR cluster. By default, the Spark submit script is included to the Linux path environment variable now. So we can just run Spark submit and put the jar file name as argument.
But now they are logging from the shell. They are going in one of the master node of cluster and then manually submitting the job. But here in our case, and go to job bin and count.jar. So that's how instead of logging into the server, I gave a mention as a job binary. Then I go to a job template to create JBT1, and then I say what kind of job is this? This is a Spark job. I could also run it as Pig, Hive, and other streaming, etc. Storm. For this purpose, this Java program is writing a Spark job, and choose the main binary which in the previous step we have created, and that was JB1, we remember, right? If there is additional library, we can mention it there, and then launch on existing cluster. Cluster is C9, that we know. Configure is here. We have to write down that's the class name of the jar file, that here, and then you give argument as the input and output. Like the way they were hard coding it in the code, we have the flexibility of writing it here to supply the input file. So the input file is there, and then add one more, which is swift : / big data. This is the output. So job on out. These are the two things, and just launch it. Once the job is launched, here it is. Go inside the cluster, and we have some, which is the Spark GUI, and monitor what is happening inside the job. We can see that it is the running application is this, which is Spark count. You can click here to kill that job, but this is what is now running, and it is completed. It has moved to finished, and inside our data processing jobs, and see the status is succeeded. The container now, we have mentioned output. Inside the output JB1 out, inside that you are seeing that the word count result has come in two parts. In part 1 we can see, and it is showing that this particular word has been repeated twice. Now let's go see, complete this part. They are running it manually.
And hit enter to run our Spark job. See, we get all the job outputs. Now we have seen how to run our Spark application on a remote cluster.